Good day everyone, and welcome to Mathematical Intelligence. And today we are going to be looking at limits of a function. And in our previous video we talked about theory of limits, where we discussed what limit is really all about. But today we are going to start from theorems on limits. Okay, so now looking at this, there are some few theorems on limits that you can apply whenever you see a certain problem. So depending on the kind of problem you have, will determine on the kind of theorem you can easily apply to further expatiate or further simplify the problem to give you an accurate answer. Okay, alright, so the first theorem here says that the limit of a constant function is a constant. That is, limit as x tends to a of f of x is equals to a constant, maybe 2, maybe 3, maybe 4, maybe any digit, any constant. The limit thing will still give us a constant function. Alright, so now also the second theorem here says that the limit of the product of a constant and a function is the product of the constant and the limit of the function. So we have a product of the constant and a function multiplied together. The limit is still the same thing as bringing out the constant and finding the limits of the function. Alright, so that is theorem number 2. What about theorem number 3? Theorem number 3 says that the limit of the sum or difference of two functions is the sum or difference of the respective limits. That is, when you have two functions being added together or being subtracted from each other, then their limit is still equivalent to finding the limit of the first function f of x plus or minus, that is addition or negation of the limit of the other function g of x. Do you get it now? Alright, so let's look at the fourth theorem here. The fourth theorem here, which says that the limit of the product of two functions is the product of their respective limits. Still the same thing as what we did earlier. When you have two functions f of x and g of x being multiplied together, it is still equivalent to finding the limit of the first function multiplied by finding the limit of the second function. As simple as that. Alright, the fifth one is also giving more insight on the previous theorem, which is saying here that when you have the limit of a quotient of two functions, it is still equivalent to find the limits of the first denominator and find the limits of the second function on the denominator. I get it now, where g of x, the limit of g of x is not equals to 0. Alright, what about number 6? Number 6 is saying that when you have the limit of the nth root of a function is the nth root of its limit, provided that the nth root of its limit is a finite real number. That is, when you have the limit of the nth root of a function, you can bring in the limit inside the nth root, and that will now give you the nth root of the limit of that function. And that is another theorem that limit is applicable to. Alright, so having known all this, let's move and dive into some examples. Let's dive into some examples on that limit. Let's solve some examples and see how limit is being calculated. Okay, so example 1. Okay, so example 1 here. Let's give an example here. Let's say we have want to find the limit as x tends to 1 of a function x squared plus 5x plus 2. So if you want to find the limit of this function, x squared plus 5x plus 2, what do you do? How do you go about it? The first thing to do here is we are finding limit at x tends to 1. At x tends to 1. So what do? You introduce what we call direct substitution first. Let's see if direct substitution work. So we are going to introduce what we call direct substitution. That is, at x tends to 1, what is the value of this function? That is, we replace x with 1. Are we getting it now? So when we replace x with 1, what do we have? We have what? 1 square plus 5 multiplied by 1 plus 2. And then what do you have eventually? You have 1 plus 5 plus 2. And then what's our final answer for this? This will eventually give us 8. And that is how you calculate the limit of that function. Another example 2, we have, let's look at a more complex example. Let's say we should find the limit at x tends to 0 of a function x squared plus 7x over divided by x, and we want to find the limit of this function. So how do we find the limit of this function? In example 1, we make use of direct substitution, but if we have to use direct substitution in example 2, we might have a problem. Let's look at it and check it out. So replacing x with 0, what we have? 0 squared plus 7 multiplied by 0 divided by 0. And because the denominator is 0, then this function becomes undefined at x tends to 0. I get it now. So you see that we can't apply direct substitution to this. So we need to first of all simplify this function. And how do we simplify? There is something we can do to this numerator that we have here. We can apply factorization. We can factorize x here because x is common. So that's exactly what we are going to do. Factorizing x, we have x parenthesis x plus 7 close bracket divided by x. Do you get it now? So when I factorize x, I have x left here plus 7. I get it now. And here this x can cancel this x here, and when it cancels, what do you have left? You have x plus 7 left. So since we have x plus 7 left here, so from this point here now, what do? We can now put our limit at x tends to 0. So at x tends to 0, we put what? 0. We replace x with 0, and then what do we have? 0 plus 7, and 0 plus 7 is 7. Do you get me right? All right. Example 3. So for example 3, let's look at another little bit complex example. Let's say we have a limit as x tends to 1 of a function. Let's give a function. Let's say we have x minus 1 divided by x squared plus 2x plus, let's say, minus 3, and if we want to find the limit of this function, it's very, very simple. If I'm to use direct substitution here, it might not work, because if I directly substitute x as 1 here, we have 1 squared plus 2 plus minus 3, which gives us 0 in the denominator, and that will give us an undefined answer. So what do? We have to break this down by what? Factorizing and simplifying. So what do? We have x minus 1. We can simplify the denominator. This is a quadratic equation. No, this is a quadratic expression, sorry. We can simplify, and when you simplify that, you have what? You have x plus 3 and what? X plus 1. So since we have this, so from this point here, not plus 1, sorry, x minus 1. So from this point here, what do? This and this can cancel out. So what you have left here, you have what? You have 1 over x plus 3 left. And now you can now replace your x with 1 as the limit at x tends to 1. And what do you have? 1 plus 1 plus 3, which gives us 1 plus 4. And that's the solution to that problem. Now let's quickly look at limit as x tends to infinity. Okay, so look at limit at x tends to infinity. So let's look at an example. Let's say we have find the limit at x tends to infinity of a function. Let's give a function. Let's say we have x squared plus 5x being divided by x cubed plus 3x squared plus 1. And then we want to find the limit at x tends to infinity for this function. Now, how do you find limit at x tends to infinity? It is a little bit different from the former ones or the former example which we solved, which is talking about just a normal limit at x tends to a certain value. Alright, so what do we do here? First thing first is to identify the x having the highest power. Identify the x or the variable x here. It can be any variable. If you are having y here, then we are using y, because we are having x here, so we are applying x to everything. So identify the variable x with the highest power, and the variable x with the highest power here is x raised to the power 3. So after identifying that, next step is to divide both the numerator and the denominator by the highest power of x. That is, divide the numerator and the denominator by x raised to the power 3. So what do we do here? Let's divide everything by x raised to the power 3. So we have x squared over x raised to the power 3. We have plus 5x divided by x raised to the power 3, all divided by x raised to the power 3 divided by x raised to the power 3 plus 3x squared divided by x raised to the power 3 plus 1 divided by x raised to the power 3, and then you have this eventually. So what do you do at this point now? So after dividing, what do you have left here? We have 1 over x left. We have 1x cancel 1 here. We have 1 over x squared divided by, we have 1 here plus 3x plus 3 divided by x here, and what else? Plus 1 over x cubed. Okay, so we have this at the end of the day. So what do we do here? Since we have gotten dividing through and we have gotten this, next step is to now exact your limit. That is, inputting your limit at x tends to infinity. That is replacing x with infinity. And what do you have when you replace x with infinity? We have 1 over infinity plus 1 over infinity square divided by 1 plus 3 over infinity plus 1 over infinity cube. And what do you do at that point? So here, after replacing everything with infinity, what is next? So now furthermore solve this. And how do you furthermore solve this? So at x tends to infinity, we have replaced everything, all the values of x with infinity, and 1 over infinity here gives me 0, and also anywhere you are having infinity, it still gives you 0. That is, 1 over infinity square is 0. We have 1 plus 0 plus 0. So that all the values of your infinity is now giving you 0. That is, all the values of your infinity is now giving you 0. And at the end of the day, what do you have? 0 over 1, and which ends up giving us 0, which is our final answer. So one of the common mistakes people do is that they divide they divide the numerator by the highest value of x in the numerator and divide the denominator by the highest value of x in the denominator, and which is not supposed to be so. What you have to do is to divide both the denominator and the numerator by the overall highest value of x. So that is one of the common mistakes I figured out a lot of students make. So, and this is where we are going to be ending today's tutorial video for today. So don't forget to subscribe and also share this video, and also do well to turn on your notification button so you can receive all our future videos. So bye for now.